Hello everyone, and welcome to the online lecture for college algebra. In this video, we're going to cover section 1.3 on equations and graphs in two variables. So let's begin the section by doing a quick review of our Cartesian coordinate system, also sometimes called rectangular coordinates. And it's comprised of two axes. We've got a horizontal axis called the x-axis, and we've got a vertical axis called the y-axis. The spot where these two intersect will be the center of our Cartesian coordinate system, our xy plane, it's sometimes called, and this point is called the origin. So what our Cartesian coordinate system does is it describes how to get to any location in this two-dimensional plane by describing that location as an ordered pair x, y. So the first component of an ordered pair, x, tells you how far you move along the x-axis, left or right. To the right is the positive direction for x, and to the left is the negative direction. And the second component, the y, tells you how far up or down you go to get to the said location. Up being the positive direction for y, down being the negative direction. So our origin, which is at the center of our xy plane, is the ordered pair 0, 0. 0 left or right, 0 up or down. That is the middle. Therefore, the intersection of these two axes breaks our two-dimensional plane up into 4 even quadrants. And so we label them numerically from 1 to 4 with Roman numerals, and we start in the top right where everything is positive. So we've got quadrant 1, where x is positive, y is positive, right and up. And then we label them counterclockwise, mainly because that's the same way we do angles. So quadrant 2 would be the top left portion of the xy plane. Quadrant 3 in the bottom left, and then last but not least, quadrant 4 in the bottom right. So let's just quickly plot the 4 points listed on the page and identify what quadrant they're located in. So let's start with this ordered pair A. If you see just a capital letter in front of an ordered pair like that, that's just the label for the point. And so this is the ordered pair 1, 4. So the 1 tells us we go 1 to the right in the positive x direction. And the negative 4 tells us we go 4 down, 1, 2, 3, 4, in the negative y direction. So that ordered pair would be right here, which means A would be in quadrant 4. Now, oftentimes you'll see labels for important points on the axes themselves. So for example, you might see a label of 1 here and a label of negative 4 here, which can allow you to more easily locate locations in the xy plane. If we take a look at point B, negative 2, negative 3, the negative 2 tells us we go 2 to the left in the negative x direction, and then 3 down in the negative y direction. So B would be located here, which would place it in quadrant 3. Point C, 5, 0, says go 5 to the right, positive x direction, 2, 3, 4, 5, 0 up or down. So C would be right here, which means it's not in any quadrant. It falls in between. So in this case, we would describe its location based off of the axis it's on. We would say that C is just on the x-axis. And then similarly for D, the 0 first says go 0 left or right. The 3 says go 3 up because it's positive. So point D would be here. And this point would then be on the y-axis. All right, so again, the main thing to keep in mind with the Cartesian coordinate system is not to get them mixed up. Remember that the first number always tells you left or right. The second number always tells you up or down. Next up, we're going to be introducing two important formulas related to the relationship between two ordered pairs. The first is the distance formula, and this is meant to calculate the distance in a straight line, so the shortest distance between two ordered pairs. Let's start off with an easy case, and I'm going to bring a little bit of trigonometry in. So let's say you have a point xy, and you want to find its distance specifically from the origin 0, 0. This actually simplifies the formula quite a bit. Well, remember what the ordered pair xy is telling you to do. X tells you go x to the right. Y tells you go y up. The distance between these 2 points is the straight line connecting them. I will label it with the letter D for distance. Well, this actually creates a right triangle, the bottom of which is how far right you traveled, x, and the right side is how far up you traveled, y. So the distance formula is actually just the Pythagorean theorem. The hypotenuse squared, which is distance in this case, is equal to the sum of the other two sides squared, x squared plus y squared. So if I want to solve this for distance, I'm just going to take the square root. So the distance would just be the square root of the x component of the ordered pair squared plus the y component of the ordered pair squared. Now, you're going to learn shortly, a couple of sections from now, that normally when we take the square root of both sides of an equation, we have to be careful with plus or minus signs. But in this case, we're assuming that distance is just a positive value. So the distance is just always going to be a positive number in this case. All right, so this is the simpler form of the distance formula, but it's built specifically to calculate distance from the origin. Let's look at the more general form, which is when you want to calculate the distance between 2 points. So now we're going to have two ordered pairs, and I want to calculate the distance between those. The first one I'm going to label as x1, y1, and the second I'm going to label as x2, y2. We are still trying to find the distance between the points. Well, the idea is still the same. I'm still going to make a right triangle out of it, but it's not going to be simply x and y anymore for the sides of the triangles. So let's do some labels on the axes to help us keep track of some things here. For this bottom point in the bottom left, that corresponds to x1 on the x-axis and y1 on the y-axis, and similar thing for the second point over here. We've got x2 for its x value, and we've got y2 for its y value. So if I draw a right triangle out of this, what would the ordered pair for this point in the bottom right be? Well, you can tell from the axes that it would have the same x value as this point here. It would have x2, but it would have the same y value as this point here, y1. And so now we can find the horizontal and vertical distance of this right triangle. So let's start with the bottom. This is going to be the distance between the x values, which you can find by subtracting them, x2 minus x1. So that's now the length of the bottom side of our triangle. All right, so just to give you a concrete example, let's say x1 was at 1, x2 was at 5, the distance between those two would be 5 minus 1, or 4. Right? 4 is how far apart 1 and 5 are. It's going to be similar for the y values. That vertical side of the triangle is going to be the change in height, which is going to, again, just be subtraction, y2 minus y1. When we relate this to slope in the next section, this is basically the run between the 2 points, and this is the rise between the 2 points. So once you get used to calculating slope, this idea will be very similar. The rise is the vertical portion of the triangle. The run is the horizontal portion of the triangle. But now that we've got the length of these two sides, we can just set it up again with the Pythagorean theorem. So the distance squared would be the bottom side squared, x2 minus x1, quantity squared, plus the vertical side squared, y2 minus y1, quantity squared. And so if we want the distance formula, again, we just take the square root of both sides, and we get the distance between two ordered pairs is the square root of the distance between the x's squared plus the distance between the y squared. This formula is definitely a little bit on the messier side when you first look at it, but if you've done any right triangle trig at all, connecting it back to the Pythagorean theorem really helps in remembering this formula. The second formula we're going to take a look at with regards to the relationship between two ordered pairs is much more straightforward. And this one's called the midpoint formula, because if you have two ordered pairs, what the midpoint formula does is, if you imagine drawing a straight line in between, the midpoint would be the ordered pair exactly halfway in between the 2 points. So let's take this back down to one dimension for a second and talk about how to find the point that's halfway in between two things. So let's say you've got 1 and you've got 3. You can probably tell by looking at these numbers what's halfway in between 1 and 3. Halfway in between would just be 2, right? So 2 would be the midpoint of 1 and 3. But if it's not quite that obvious, how would you go about finding the midpoint? Well, in truth, you're just going to average the two endpoints. So if you want to figure out what's halfway in between, you can just add up the two numbers, divide by 2. Just take a simple average of the two numbers. That would give you 4 divided by 2, or the midpoint of 2. So for example, if you had, instead of 1 and 3, let's say 2 and 7, and you wanted to find the number halfway in between those, you could just average them together. 2 plus 7 divided by 2, which would be 9 divided by 2, or 4.5. Right? Makes sense because you go 2.5 to get from 2 to 4.5, and you would go another 2.5 to get the rest of the way to 7. It really is halfway in between. And so now we're just going to generalize that into 2 dimensions instead of 1. So if you've got an ordered pair, x1, y1, and x2, y2, if you want to find the point halfway in between them, well, its x value is just halfway in between the x's, and its y value is just halfway in between the y's. So all you have to do is find the midpoint of the x's to get the new x coordinate, and find the midpoint of the y's to get the new y coordinate. And so that's what we're going to do. To find the number halfway between the x's, you're just going to average them. Add them up, divide by 2, and to find the midpoint of the y's, you're just going to average those. y1 plus y2 divided by 2. And so our formula for the midpoint between 2 points, and we describe it as the midpoint of the line segment connecting them, right? Just like I drew this dotted line in the figure up here, is just given by average of the x values is the new x value, average of the y values is the new y value. So these are our two formulas related to the relationship between ordered pairs, finding the distance between the ordered pairs, and finding the midpoint halfway in between the line connecting the two ordered pairs. So let's take a look at some examples involving both. So in example 1, we're going to be given pairs of ordered pairs, and we're asked to find both the distance in between and the midpoint of the ordered pairs. So try pausing the video here and see if you can find those values for example 1's part A and B. All right, well for part A, let's start with distance. And I'm going to actually break this up into parts just to really illustrate what's going on here. And that's to remember that it's essentially the distance between the x's squared plus the distance between the y squared, and then you take the square root because of the Pythagorean theorem. So I'm going to start by finding the distance between the x values. So that would be from -3 to 9. You can always just subtract to find the distance. So if I do x2 minus x1, 9 minus a -3 would turn into 9 plus 3. So that's the distance of 12 between the two. The distance between the y's, similarly, y2 minus y1 would be 3 minus a -2. 3 and -2 are 5 apart. So the distance would be the square root of the sum of those distances squared. Square root of 12 squared plus 5 squared. So that would be the square root of 144 plus 25, which works out to the square root of 169. And since 169 is 13 squared, that works out perfectly to 13. Now that oftentimes won't be the case, and if that's true, you just simplify the square root as much as possible. Next up, we've got the midpoint. And the midpoint, you just average the x's, average the y's. So I'm going to add the two x's together, -3 plus 9, cut it in half, add the two y's together, -2 plus 3, cut it in half. So for the x values, -3 plus 9 would be 6. -2 plus 3 for the y value would be a +1. So that would just reduce to 3 1/2. I think the thing that trips people up the most with these two formulas, because we learn them at the same time, is to keep track of the fact that we're subtracting the x and the y values in the distance formula, and that's because we're just trying to find the distance in between the two, whereas we add the x and the y values in the midpoint formula, and that's because we are averaging them, and adding is part of averaging, whereas subtracting just tells you how far apart they are. All right, similar idea for part B. Part B is only just a little bit more complicated because of the fact that the x value of the second ordered pair is a little bit more complicated. -1 plus 4 square root of 3 is all x2. It's all before the comma. So let's start with distance. So I'm going to start by finding the distance between the x values, x2 minus x1. In this case, x2 would be the -1 plus 4 square roots of 3. We want to subtract from that x1, which is -1, but that turns into a +1, which just cancels out with the -1 that we started with. So the distance between the two is just 4 square roots of 3, which makes sense because this is -1 and this is just -1 plus some amount. So that amount that's added is the distance between the two. For the y values, we've got y2 minus y1, which would be 12 minus 8. So those would be 4 apart. And so now we can find the distance by taking the square root of those two distances squared. Distance between the x's squared plus distance between the y's squared. Now we've dealt with stuff like this back in chapter P. If you've got 4 square root of 3 squared by property of exponents, exponents distribute across multiplication and division. So that would be 4 squared times square root of 3 squared, or 16 times 3, right? It just gets rid of the square root sign on the 3. So that would give us 48. And this is plus 4 squared, which is 16. So we combine those together to get square root of 64, which is just 8. Right? We also still need to do the midpoint. This one is not going to work out as nicely. But that's fine. The final answer does not have to be pretty. So I'm going to add the x's up. x1 plus x2 divided by 2. So we've got -1 plus -1 plus 4 square roots of 3. And same for the y's. y1, 8, plus y2, 12, divided by 2. And this is another example of two numbers, 8 and 12, that you might just be able to look at and tell what's halfway in between. So this time around, because we're not subtracting, the minus ones don't cancel it with each other. It's just -1 minus 1. So we get a -2 plus 4 square roots of 3 over 2. And then 8 plus 12 is 20 over 2. And then the last thing we can do here is reduce this fraction on the left a little bit, because 4 is divisible by 2 and 2 is divisible by 2. So we can reduce this fraction to give us a -1 plus, in fact, let me write this somewhere else to get a little bit more space. I'm going to put it in the top right corner. That would give us a -1 plus 2 square roots of 3 for the x value, and for the y value, 20 divided by 2 is just 10. Right? And so that's the final answer, but just in case that x value wasn't quite enough detail, I'm going to write it out as an extra step. So if I had just factored a 2 out of that numerator, that would leave you with a -1 plus 2 square roots of 3. And then the 2 would reduce with the 2 down below. All right, so next up we're going to take a look at two types of specific graphs here in section 1.3. The first of which is circles. How do their equations look? How do their graphs look? So by definition, in our Cartesian coordinate system, a circle is the set of all points in a plane that lie a fixed distance from a given point in the plane. That given point being the center of the circle. So you're going to have some center location, and then the circle will be all points that are a fixed distance from that center in any direction. And of course, that distance we call the radius of the circle. And so the equation of a circle always involves x squareds and y squareds. And the general form of the equation of a circle looks like x minus h quantity squared plus y minus k quantity squared is equal to r squared. X and y are just the independent and dependent variable for the equations themselves. Those will stay as x and y, but h, k, and r will be numbers in an actual equation, and they mean something. Hk is the center of the circle. H, the x value of the ordered pair, is paired off with the x, makes sense. K, the y value of the ordered pair, is paired off with k, makes sense. The one thing you have to be really careful about here is that there is a minus sign built into the formula. So it's always the opposite sign of whatever you see in parentheses, and that's something that's going to pop up pretty frequently in algebra. So if you have x minus 2 quantity squared plus y minus 3 quantity squared is equal to some other number, we'll get to that in a second, then the center of this circle would be positive 2 for x, positive 3 for y. Whereas on the other hand, if you had something like x plus 4 quantity squared plus x minus 1, or excuse me, y minus 1 quantity squared, then because x plus 4 is x minus negative 4, your h would be negative 4, and your k would still, in this case, it's still minus, so positive 1. Right? So it's always the opposite sign of what you see in parentheses because of the minus sign built into the formula. Be careful. And then on the right-hand side, you've got r squared, and r represents the radius of the circle. But remember, this thing on the right-hand side is not the radius itself, it's the radius squared. So if we go back up to this example over here, this would represent a circle with a radius of 3, because 3 squared is 9. You can always just take the square root of that number on the right-hand side to figure out what the radius of the circle needs to be. Now, this actually simplifies quite nicely if you happen to have a circle centered at the origin, because then h would be 0 and k would be 0, right? The center of the circle is at the origin 0, 0. And so this x minus 0 quantity squared just simplifies to x squared. The y minus 0 quantity squared would just simplify to y squared, and the thing on the right would still be the same. So if the circle is centered at the origin, it's just x squared plus y squared is equal to the radius squared. Now it is important that you get familiar and you remember this general form for the equation of a circle. That is something I will expect you to know, so keep that in mind. All right, so in example 2, we're given the equation representing a circle, and we're asked to determine its center, its radius, from the equation, as well as doing a rough sketch of its graph. And now the graph doesn't have to be perfect, it just has to be somewhat accurate. Make sure that you represent the radius and the center at least mostly correct, right? It doesn't have to be a perfect circle that you draw. So let's start with part A. We've got an equation that is just x squared plus y squared is equal to 9. All right, so again, you should learn to watch out for that special case. X squared plus y squared is equal to 9 is just a simplified version of x minus 0 squared plus y minus 0 squared is 9. This is a circle whose center is the origin, and then again, remember to be careful, common mistake, that 9 is the radius squared. So the actual radius of this circle would be square root of 9, or 3. All right, so in order to do a decent sketch of the circle, what I like to do is I start with the center, and then I go out the radius to the left, right, up, and down. And then from there, I'll try to draw a circle through those 4 points. So if I go 3 to the left, negative 1, negative 2, negative 3, 3 up, 3 to the right, and then 3 down. So that gives me 4 points that should all be equally spaced from my center. And now I'm going to do my best to draw a circle between them. No judging. I won't judge you for your circles if you don't judge me for mine. And we get a circle that looks a little bit like this. Part B will be pretty similar. These problems go fast as long as you recognize the formulas. The only thing you have to watch out for here is this is not in standard form currently, right? We want our x's and y's to be on the same side of the equation. So what I'm going to do is I'm just going to add x minus 4 quantity squared to both sides, move this whole parenthesis over to the right, which makes it positive. Right, and this gets us more like what we're expecting to see. So if we just read the information then, remember, flip the signs. The center would be positive 4 for the x value and negative 2 for the y value. And then if r squared is square root of 20, or excuse me, r squared is 20 itself, r would be the square root of 20. Now we can certainly simplify that, and we should, because 20 is 4 times 5, so this would be 2 square roots of 5. Now this one's going to be a little bit trickier to draw, and this is why we really can't sketch it perfectly, because this radius is not a nice round whole number. So I'm going to have to do some guessing as I go. So let's start with the center. That one's easy enough. I'm going to go 4 to the right, 2 down for 4, negative 2. So there's my center. Redraw those for reasons you'll see in a second. And now I need to at least approximate the radius. So you could plug this into a calculator to get a decimal for it. You guys have access to those in this class, so that's not a big deal. You don't need to go out further than 1 decimal place. Just kind of eyeballing this, square root of 16 is 4, and square root of 25 is 5. So since 20 is in between these, this is probably going to be in the neighborhood of 4.5. And plugging this into a calculator, that was pretty close. This is 4.47. So if I rounded it to 1 decimal place, it would be about 4.5. Now I'm probably going to go a little bit off of my guide over here, but that's okay. So if I go 4.5 to the left, 1, 2, 3, 4.5, 4.5 up, 1, 2, 3, 4.5, 1, 2, 3, 4.5, and then 1, 2, 3, really guessing at this point, 4.5. I get my 4 points that I'm going to draw my circle through. I'm going to clean this up a little bit. And so we get a graph that looks a little bit like this. Not my best circle, but functional. For example 3, we're going to work in the other direction. So in example 2, we were given the equation and we were asked to pick out the center and the radius. In example 3, we're going to be given a center and a radius for a desired circle, and we're going to use that to build the equation. And this direction is pretty easy, at least for parts A and B here. We'll see a little bit of a twist on it in just a second. But as long as you know the formula, x minus h quantity squared plus y minus k quantity squared is equal to r squared, you just plug h, k, and r in from the center and the radius respectively. So for part A, if the center is 0, 0, the origin, we just get x squared plus y squared. And if we want a radius of 5, and the right-hand side is r squared, this would be equal to 5 squared, or 25. All right, for part B, we've got a center of -1, -6. Remember, the minus sign built in is going to change these signs. So if you plugged in -1 for h, that would turn into x plus 1 squared. Same thing for the y. That's going to be y plus 6 quantity squared. And this is going to be equal to r squared, 1/3 squared, which is 1/9. Now part C has a bit of a twist to it, and it makes the problem a little bit more complicated. This time we're asked to write the standard equation of the following: a circle with a center at -2, -3, and passing through the point 2, 5. So what you'll notice is that they didn't give us the radius here. The left-hand side of the equation is still really easy to put together, but what do you put on the right-hand side? Instead of giving us the radius, they gave us a point that the circle passes through. So just to do a rough sketch here, our center is going to be at -2, -3, and we know the circle is going to pass through the point 1, 2, 3, 4, 5, 2, 5. So we've got a really large circle here. Really rough sketch. So the trick is to recognize is that the radius of this circle, because you know the center and you know a point on the outside edge, the radius is the distance between those 2 points. So this is our first application of the distance formula. We can calculate the distance between these 2 ordered pairs, just like we did in example 1, in order to figure out r. And then at that point, this problem becomes exactly the same as parts A and B. It'll be pretty straightforward. So let's start with the distance formula. I'm going to find the distance between the x values, x2 minus x1 would give us a distance of 4 between -2 and +2. Now I'm going to find the distance between the y values, and you can just count because I sketched. You could count up to figure the distance, but subtraction works just as quickly. So we would have y2 of 5 minus a y1 of -3, which would give us 8. And so the distance, which is the radius in this case, so I'm just going to go ahead and replace it with r, would be the square root of the distance between the x's squared plus the distance between the y squared. So in this case, it would give us square root of 16 plus 64, which would give us square root of 80. Now this is a square root that you can simplify, but we're not going to. Simplifying is unnecessary, and you'll see why in just a second. I'm just going to leave r as square root of 80. Now we can jump straight to putting the equation together. So we're going to have x minus, reading the center for h and k now, x minus h would turn into x plus 2 quantity squared, plus x minus k would, y minus k would turn into y plus 3 quantity squared. And then here's why we didn't need to simplify r. It's equal to r, which is the square root of 80, squared. So the square root would just get squared away here. And so our final answer is going to be x plus 2 squared plus y plus 3 squared is equal to 80. The second type of graph we're going to look at in this section are one of the most basic graphs that exist, lines. Now, there are a bunch of different forms that you can write the equation of a line in. Standard form is of the form ax plus by is equal to c. That kind of corresponds roughly to our standard form for the circle equation that we were looking at a little bit earlier, where the x and y are on the same side of the equal sign. Probably the most used form for the formula of a line is called slope-intercept form. That's y is equal to mx plus b. You don't really need to know these forms yet, because we're going to spend an entire section talking about lines and their equations in 1.4. Here, we're just going to be graphing the equations given to us, so we don't have to worry about it so much. The key feature that you can take away from this, though, is that to be an equation circle, you had to have both an x squared and a y squared, but when dealing with a line graph, it's an x to the first power and a y to the first power. Now, truth be told, if you have any 2 points, that's enough to draw the graph of a line, because it's just a straight line going through those points and continuing infinitely in both directions. Lines never stop. Right? If it was something that stopped, we have a different name for it, something like a ray or a line segment, depending on how it works. But for a line, it goes infinitely. Now, although you can plot the graph of a line given any points, we're going to use 2 specific points in this section, and those are called the intercepts of the line. So if you take a look at this graph over here, this point here, where the line intercepts the x-axis, is appropriately called the x-intercept. And the point where it intercepts the y-axis is called the y-intercept. Now, because the intercepts are on the axes themselves, that guarantees some things about the point. For an x-intercept, because it has to be on the x-axis, that means you can't go up or down, which means the y value is always equal to 0 for the x-intercept. And similarly, for the y-intercept, you can't go left or right or you'll be off the y-axis, which means the x value is equal to 0. And so what that does is it gives us a process for finding these intercepts. If you want to find the y-intercept, you plug 0 in for x and simplify. And if you want to find the x-intercept, you plug 0 in for y and simplify. So a good way to remember it is to find intercepts, you plug in 0 for the other variable and simplify. Y-intercept, plug it in for x. X-intercept, plug it in for y. And now, although we're talking about these with respect to lines in particular right now, this is actually true of all graphs, no matter what you're working with. Once we start talking about quadratic functions later on in the course, you want to find x-intercepts, plug in 0 for y. You want to find y-intercept, plug in 0 for x. That will always be true. All right, so in example 4, we're asked to find the intercepts of the following lines and graph. And finding x and y intercepts of lines, pretty easy equations for the most part. Now, we're going to try graphing these freeform by hand to get used to how you would go about this process if you don't necessarily have a grid in front of you. So let's start with part A. I'm going to start by finding the intercepts. So it doesn't matter what order you do them in. Let's say I want to find the y-intercept first. That means I would plug in 0 for x. And since that would be 2 times 0, that whole first term would go away. So we would just get 3y is equal to 6. Or if we divide both sides by 3, y is equal to 2. So that is giving you the y value of the intercept. Remember that the x value is guaranteed to be 0. That's how we find it in the first place. So as an ordered pair, you would have the point 0, 2. And I went down on this graph, but since it's positive 2, it would have gone in the upwards direction. All right, but again, I'm not graphing it up here. This is just a preview. Similar for x-intercepts. This time I'm going to plug in 0 for y, which would make that term go away. So we just have 2x is equal to 6. Divide both sides by 2, you would get x is equal to 3. So our ordered pair would have an x value of 3 and a y value of 0. So these are pretty close to the origin overall, which makes this line pretty easy to graph. So our y-intercept is up at positive 2. The key when you're drawing these by hand is to try to keep your tick marks on the axes as equally spaced as possible. Otherwise, things get a little bit wonky. Obviously, you can't do it perfectly, but that's okay. And then our x-intercept is at positive 3, 3 to the right. So it would be somewhere over here, which means our line, the straight line connecting these two dots, would look something like this. Now, because I am drawing this by hand, I am going to label a couple of points on the axes, at least 2 on each, to indicate the scale that I'm using. This is going to be really important for part B, because let's find the intercepts for part B. So for the y-intercept, I'm going to plug in 0 for x. I want to solve the equation 3y minus 90 is equal to 0. So if I add 90 to both sides to move it across, divide by 3, we would get y is equal to positive 30. So the y-intercept is all the way up at 30. We're not going to want to count by ones for this graph. As an ordered pair, x of 0, y of 30. For our x-intercept, this one's going to be really easy. We plug in 0 for y, which makes that first term go away. And we don't even have to solve the equation, it's already done. We just get x is equal to negative 90. So our ordered pair would have an x value of negative 90 and a y value of 0. So it seems like the go-to here, if I'm dealing with a 30 and a 90, is probably to count by tens. Not the only way you could do it. Counting by 15s would probably also work out pretty nice. But I'm going to count by tens. So in the y direction, I'm going to have 10, 20, 30 for my y-intercept. And then we have a negative x this time, so I'm going to go to the left, negative 10, and then I'm going to skip. You don't have to label every single one. Negative 20, 30, 40, 50, 60, 70, 80, 90. And so this line would look something like this. Let's talk quickly about some special cases, and those are lines that are perfectly horizontal and perfectly vertical, because their equations look a little bit different. In fact, you'll find one variable missing out of each. So in order to illustrate the point, let's pick an ordered pair or two on each line. So starting with the horizontal line, let's say I pick this point right here. Its ordered pair, because I went negative 1 in the x direction, would be negative 1, and the height is at 3 in this picture, so that would be the ordered pair negative 1, 3. Maybe I also pick the point over here. And so that one would have an x value of positive 3, and it would still be at the same y value, the same height. And in fact, no matter what you pick for a point on this line, its y value is always the same height. And so if we want to describe a line like this, all you need to do is say that the y value is equal to 3. This describes every ordered pair on this line. And so anytime you have a line equation of the form y is equal to some constant k, this represents a horizontal line at height k. We can do something very similar for the vertical line down below. So let's say I pick the point right here on the axis. That would be negative 1 to the left, 0 up and down. Or if I pick this point up here, that would be negative 1 to the left, 2 up, so negative 1, 2 for the ordered pair. So the key feature about all of these ordered pairs on this line is that the x value is always equal to -1. So x is equal to -1 describes every ordered pair on this line. Anytime you have the equation of a line that is x is equal to k, that represents a vertical line at an x location of k. Another way you could try and keep track of which is which to not get them mixed up is to think of it in terms of the intercepts that we were doing before. So you'll notice that a perfectly horizontal or a perfectly vertical line, unless it's on one of the axes themselves, will only ever have one type of intercept. So a horizontal line will only have a y-intercept, again, unless it's the x-axis itself. And a perfectly vertical line will only ever have an x-intercept. All right, so if you see x is equal to -1, it's basically describing the only intercept it has, the x-intercept. All right, so you end up with a vertical line. And if you've got y is equal to 3, it's describing the only kind of intercept it has, a y-intercept. So let's graph some of these special equations. And it says specifically graph the following equations by plotting points because, again, if you're ever not sure, you can just pick two ordered pairs. So if you get y is equal to -2 and you have trouble remembering, is that a horizontal line or is it a vertical line? Just plot two ordered pairs with a y value of -2. That's all you got to do. We've got 0 left and right, 2 down. We've got 1 to the right, 2 down. Two ordered pairs that have a y value of -2. This line is a horizontal line at a height of -2. All right, part B takes a little bit of rearranging because this is not in the form x is equal to k right now, but the fact that there's no y there tells us we can make it that way by combining like terms. So if I subtract the 5 from both sides, still got the -x. 4 minus 5 would give us -1. And if I multiply both sides by -1 to flip the signs, that equation simplifies to x is equal to 1. So again, if you forget what type of line it is, just pick two ordered pairs that meet that condition. An x value of 1. So we got 1 to the right, 0 up or down. 1 to the right, 1 up. Those both have an x value of 1. This creates a vertical line. The very last type of problem in this section is perhaps the easiest once you learn how to do it, and this is using graphing software to help you solve equations. And the way you do that is you always move everything to one side of the equation, set it equal to 0, and then swap that 0 out for y in terms of graphing. So if I want to solve the equation -20 plus 5x is equal to 0, I'm just going to graph -20 plus 5x. Y is equal to -20 plus 5x. And if you do that, compare these two equations, and what do you notice? Y is equal to 0. So where y is 0, that's the solution to the equation. Well, y is 0 at the x-intercept, right? By definition, that's how we find the x-intercept. And so let this be a lesson. Clearly, this is an equation that you could solve pretty easily just using straight up algebra. But once you start getting to messier types of equations, if you have graphing software available, which of course you want on the exams, so this is more of an out in the real world type of thing. If you move everything to one side, set it equal to 0, and graph it, the x-intercepts are the solutions that you're looking for. So in this case, the x that solves this equation is the 4 of the x-intercept. You can verify this quite easily by just adding the 20 across to the other side and dividing both sides by 5. All right, so that is it for section 1.3. In terms of types of problems in this section, there's a little bit of variety. Make sure you know the distance and midpoint formulas and how to apply those. Takes a little bit of memorization, but again, keeping in mind where they come from helps with that. The distance formula is basically the Pythagorean theorem. The midpoint formula is just average the x's, average the y's. Given the equation of a circle, you should be able to identify the center and the radius and do a rough sketch of the graph, or vice versa. Given a center and a radius, be able to build the equation of a circle. And this should also hold for part C of that example. Given the center and a point, use the distance formula to find the radius, and then build the equation for a circle. So what that means is that, again, I expect you to know that equation, x minus h squared plus y minus k squared is equal to r squared. And then the last type of problem in this section is, given the equation of a line, be able to find the x and y intercepts and use them to graph. And know how to handle those special cases as well, horizontal and vertical. I'm not going to test you on that very last example on the test of finding the solution from a graph. That won't be a thing. All right, so again, this was just a really basic introduction to lines in this section, finding intercepts and graphing, because we're going to spend a whole section next up talking about lines. So with that said, as always, if you guys have any questions, please make sure you let me know, and I will see you in the next video.